Hey everyone, it's Justin again. I'm working with a nonprofit organization today, helping them to do some handiwork and get this home fixed up. Did you know that I can install light fixtures and fix drywall? Yeah, I'm pretty handy. And to be prepared for all this work today, I didn't just bring one or two tools with me. No, I brought an entire toolbox and even more than that, just in case they're useful. It's always best to have all my options ready so I can get things done quickly and efficiently. Knowing how useful it can be to have all my tools available for a project got me thinking about our systems unit. There's still one more method of solving that I can teach you so that you can have all your tools available too. You already know how to solve a system of linear equations using graphing and using substitution. Next, you get to learn about the elimination method. Then once you know how to use this final method, you'll have all the tools you need so you can pick the right one for the job. So, let's talk about the elimination method. To use this method, the equations must have the terms with the same variables, equal signs, and constants lined up. Take this system, for example. We can see that the x term comes first in each equation, then comes the y term, and then the equal sign, and then the constant. Everything's all lined up. There's one more thing that's necessary to use this method. The coefficients in front of one of the variables must be opposites. Like here, in front of y is positive 3 and negative 3. Those are opposites because they would add up to be 0. Or take this system, for instance. This has the y terms lined up, followed by the equal signs, then the x terms, and then the constants. And do you see opposite coefficients in front of one of the variables? Yeah, the x variable has positive 5 and negative 5 as coefficients, and those are opposites since they add up to 0. Having the like terms and parts of the equations lined up, along with opposite coefficients in front of one of the variables, are the keys to being able to use the elimination method. And if any of these requirements aren't fulfilled, we have these skills to manipulate the equations and get them ready ourselves. All right, now that we know about the setup needed for the elimination method, I think we're ready. Let me officially show you how to use it. Let's work with this system. First of all, how do we know this system is ready to use elimination? Yeah, similar parts of the equations are in the same order. The x terms are first, then the y terms, then the equal signs, and finally the constants. The matching terms and parts of the equations are lined up in the same order, and we also have opposite coefficients in front of one of our variables. Which variable do you see opposite coefficients in front of? It's not the x terms this time. 5 and 3 here are not opposites. Yeah, it's the y terms. They have positive 2 and negative 2 as their coefficients. As long as one of the variables has opposite coefficients, we'll be good to go. So since we know this system is ready to use elimination, we get to use a little mathematical fact to our advantage. Remember how both sides of an equation must be equal to each other? Even if we don't know what each variable represents, we do know that this left side equals this right side. And we also know that this left side equals this right side. And if we have two equivalent expressions, we can add them to both sides of the top equation, and the resulting equation that we get will still be true. That means I can add these expressions together and then add these expressions together, and we'll still have a true statement. Okay, let me show you. Let's add up what's on the left side of our equations first. 5x and 3x add together to equal 8x. 2y and negative 2y add to equal 0? Nothing. 0. They cancel each other out. Let's bring down the equal sign and then add our constants together. 27 and 13 add to equal 40. Okay, look at the equation we have now. What happened that makes this equation so nice? Think about the name of the method we're working with. Does that give you a hint? The y terms were eliminated. We only have x now. We have eliminated a variable using the elimination method. Whew. I know. You're probably thinking, Justin, it's not that exciting, but I just love it when the title matches what we're doing. Elimination. Okay, let's get back to solving. So now we have 8x equals 40. What do you think we should do next? Yeah, that's a very nice equation to solve. Dividing by 8 gives us that x equals 5. Now, we still need to solve for y. How do you think we can do that? How would you have gone back to find the value of the other variable when using the substitution method? Exactly. Pick one of the original equations and substitute 5 in for x. Then solve for y. Or even better, do it in both equations to make sure you get the same answer for the y value each time. That's always a good way to check your work. So let's see. Here, we get that y equals 1. And here, we get that y equals 1 again. Perfect. Let's include that in our ordered pair. Now that we've just gone through this problem, how would you summarize the setup involved in the elimination method and the process of elimination? There's a place in your notes to pause and summarize what you've learned so far. Pause the video now so you can take some time to do this. I would say that we first needed to make sure our equations have like terms and similar parts in the same order. For example, here we had x terms, y terms, then equal signs, then constants. Then we also needed to make sure that one of the variables would cancel when we added the left sides and right sides of the equations together. This will happen when one variable has opposite coefficients, which in this example happened here. Our y terms were positive 2y and negative 2y. Positive 2 and negative 2 are opposite coefficients, so they will cancel each other out. Once we knew the equation was set up for elimination, what did we do? Yep, we added both sides of the equation, and a variable was eliminated, so we could solve for the variable that was still there. Then we used the value of that variable to go back and find the value of the other variable, either using the top equation or the bottom equation, or both, to help make sure we didn't make a mistake. So, elimination. What do you think of this process so far? If you want to go through that explanation and summary we just did again, now is the perfect time to go back in this video for another recap. Do that now if you think it'll help you. Okay, are you ready to officially try this process out for yourself? Here, let's do an example problem. This says to solve the system of equations using the elimination method. So first of all, is this set up to use elimination? How do you know? Yeah, the similar parts of the equations are lined up. First, there's the y terms, then the equal signs, then the x terms, and the constants. And I see opposite coefficients in front of one of the variables, in this case, the x terms. We are all set to use elimination, and I want you to try solving this problem on your own. I know you can do it. Pause the video now and use elimination to find the solution to this. Did you add up both sides of the equation to see what would eliminate? 5y and 2y add to be 7y. 2x and negative 2x add to be nothing. And finally, 25 and negative 4 add to be 21. Well, look at that. The x term was eliminated. Now we just have an equation with y in it. And solving this gives us that y equals 3. Did you get y equals 3? If not, pause the video for a few moments to figure out where your mistake was. Okay, what's next? We only have half of our answer, so what should we do? Yeah, let's substitute 3 into either or both of these original equations for y and solve for x. Let's see here. I'm getting x equals negative 5. And if I check the other original equation in the system, then I also get x equals negative 5. So it's settled then. The x value is negative 5. And that, my friends, is the elimination method. So, how does it feel to have another tool for solving systems in your toolbox? You'll see soon in this unit that having options can be a very good thing. Now that you're finishing up your guided notes, be sure to complete the activity in your PDF to help ensure you're successful in the online practice. All right, it's time for me to go fix some walls and ceilings and get some electrical work done. I love helping others out, and I bet I'll get to use a lot of my tools. Always best to be prepared. Good luck on your practice, and I'll see you next time.